Hello, everyone. Welcome to our beginner-friendly system design series. Before we get started, I want to give you an overview of the event series itself. So the goal of these talks is to help you get started with system design on real-life app examples. And during each event, we are going to talk about how to build certain app from scratch. We will focus on 3 to 5 core features that make that system unique. And again, like no coding, just conceptual overview and diagramming. Today's event is called How to Build PayPal from Scratch. And we are going to focus on its 3 core features. So the first one being sending and receiving money, then multi-currency and cross-border payments, and the last one, fraud detection and security. So our next event is going to be very soon as well. So please follow our LinkedIn and YouTube and our community pages to be notified once we post a new event. I'll share the community page links in the comments. And yeah, we also want today's session to be as interactive as possible. So feel free to drop any questions you have in the chat. And now I want to introduce you to our special guest today, Matt, who's a cloud architect and potentially a future GD. So welcome. Thank you so much for joining us.
Thanks for having me. I'm happy to be here.
Great.
All right. So should we just dive in?
Yep. Yeah, let's do
it. So when you first told me, hey, let's talk about PayPal, I was like, oh, this got to be easy. And then as I kept thinking about it more and more, I was like, oh, wait, this is probably really complex. Because, PayPal, when we think about it at a very base level, when it first started, it probably was a simple idea. The idea that I could send you something, right? Like every day, we already do that. I send you an email, you have that email. I send you an IM or sort of a chat message, you get that. And so it's really easy when you think about it from that perspective. Let's start putting some stuff up on the board here. We'll put that, and then we'll do another one. Oh, let's move it over here. And we'll put Alexander. There. Okay. So if I wanted to send you something in the real world, I would physically send you a letter, a message, right? Mm-hmm. And that message would go from me, and it would go all the way to you, right? And you would have it, and I wouldn't have it anymore. And that's how we normally would transact with money or anything else, whether it's a barter or anything like that. And that's, a really simple system. But the problem is then I have no record that I gave it to you. And if you lose this message, you have no record that I gave it to you either. Mm-hmm. So we really need a database, obviously, to keep track of this. And then that allows us to make it virtual too. So I'm just going to scoot some stuff over a little more to each side. And let's try to create a database. Do we have a database icon here? Here we go. Perfect. It even says database, right? Yeah. So ideally, we'd be keeping track of this message in the database. And I'll probably change this from a star to something else just so that we can start tracking information in it. And this database, of course, is in the cloud, right? You could store it locally, I guess. You could put it in a server closet, but ideally, it's going to be in the cloud. Let's do that. There we go. So we have a database in the cloud. You and I have computers or phones or whatever devices we have that are going to be connected to that cloud. And then we have the messages that are going to be in the database. I'm going to go ahead and rewrite that message. We'll make it a little square block. Oh, that's a big square block.
Yeah.
Let's do that one more time. Okay. And so in here, it's going to say something like Matt sent to Alexander. Let's just say $1. Let's keep it simple, right? Mm-hmm. In fact, let's not even say $1. Let's just say a message, right? So if the message was, hi, that's it. When you log in to your to this website, let's just say, let's not call it PayPal. Let's call it something else. PayBuddy.
Yeah.
We'll call it PayBuddy. When you log into PayBuddy, you're gonna see that essentially a query is going to be done saying, show me all messages to Alexander, and you'll see, oh, Matt said hi. And when I log in, I could say, show me everything that I've sent in the past, and I'd see the same message, Matt sent hi. And so when we think about a message, it actually is a lot simpler, right? And if we were to go back in time to, I don't know, really olden days where accounting was done in a book, there was this concept of just a single ledger entry, right? So a single row in a spreadsheet, let's say. And actually, now I'm going to go ahead and open up a spreadsheet. So this would be like a single ledger, and let's just say today's date. Today's 7th. Right? And you could get away with something like this. But this is not best practices for accounting. So at some point in the past, we could look at when, it doesn't really matter, accountants realize, hey, this single ledger idea is not a good idea, because we often have more complex transactions. Plus, when we want to do the math to figure out, well, how much does Matt currently have today? And how much does Alexander currently have today? It's a lot harder when we're trying to compare in two different columns, the froms and the tos. And so at some point, this concept of double ledger entries came up, was invented. And it's similar. It's basically, it's kind of like a parent-child relationship. So each transaction, let's go ahead and add a new column here. And there may even be something like a part ID too, or something like that. So transaction ID, we'll put 0001. Oh, that didn't work. Let's put 1001. And then let's put like I'll put 01 in here. And it probably would have like a decimal place or something like that. But that's okay. And then we'll put a 2 in here, right? And so it's going to be the same transaction with two parts to it, or two children to it. So we're basically we're using a database instead of a spreadsheet, right? That's the upgrade from a spreadsheet. Spreadsheet, everything is flat. We have one table, or maybe multiple tables, but they're not really related to each other. Whereas when in a relational database, we then can start to have the structure where things are more complex.
Yeah. So like with multiple parts, it would be like multiple people sent to the. Or
it could be multiples, yeah. It could be that it's made up for different reasons, right? So if you think about description or line items and things like that.
Okay.
And so what we see with let's do this and this and this. Okay. And so in this case, it wouldn't be amount, it's just credit and debit. And so what this allows us to do is then do those roll-ups, do the math much more easier, because the account column is always the single column.
Yeah.
And so if we think about doing a query, we're essentially, if there's a from and a to, we're really doing two queries. We're doing a more complex query. Show me everything where Matt is in the from column, and I'm going to have to do the math a certain way when Matt's in the from column. Show me everything where Matt's in the to column, I have to do a certain way, versus doing it this way. In this case, we'd be debiting Matt $1 and crediting you $1, and maybe the description or the memo is happy birthday.
Okay.
Right, something like that. And so this is so far pretty straightforward, but you could see it could start to get a lot more complex, because maybe, like you said, maybe I'm doing a multi-person transaction, and so I'm sending $10 to $1 to 10 people, and I can do that in one transaction, right? By just adding more and more rows. So it changes to 10, and then I would do this down here as many times as needed, and each one would have then a little part to it, a little line number. Right. Something like that. I think I actually need one more. Yeah. So you could do something like that. And this is all assuming that we're sending within a system that's closed, right? So we're not even talking about the real world yet. We're just talking about sending stuff within this app.
Yeah.
But that's, high level why we need a double ledger entry, so that we can start to have a more complex structure, and start to then deal with situations where maybe one thing worked and something else didn't work. You don't want to necessarily roll back the whole transaction. You could do partial rollbacks and so on and so forth.
Yeah, makes sense. There's one quick question. Does the transaction ID remain the same for all of them? I think no, right? Or
well, yes and no. So this is the parent transaction ID, right? So there's this initiating factor, right? Something happened to initiate this. In this case, it's me saying I want to send money, And so that transaction ID would be the same.
Mm-hmm.
And these are all linked to it. Now,
Yeah.
they could still have their own database IDs.
Yeah.
That, maybe to the left it's more hidden, or it could be that this is the database ID, right?
Yeah. It's my
Right. So
key is
10,000,
yeah.
100,001.2 could be the database ID. It
Yeah.
doesn't really matter. At the end of the day, all that matters is I can tie this row 3, to the transaction on row 2, and I can tie all the other ones to the one as well.
And just to clarify, essentially, like any transaction would have at least two records, right, in this table, just because one for sending and one for receiving, right?
Yeah, and so it's not sending and receiving. It's crediting and debiting.
Okay.
It's crediting and debiting accounts. So if you think about, and this is how it works in accounting tools, right? So this is an accounting class now, not a technical one. And I'll zoom in a little just to make this bigger. So what these accounts could be anything, right? This could be checking, and it could be savings, right? Let's change that to 10. So if you make a transfer within your own funds, we still want to record it twice, because then when we go to do a query, it's much simpler to say, show me all transactions where the account is this account, as opposed to show me all transactions where the from is this account or the to is this account. That's a more complex query, right? And behind the scenes, we have credit and debit here, right? But behind the scenes, we might have a hidden field that's called amount, or let's just call it hidden amount, right? And credits are going to be positive 10, in this case, and debits would be negative 10. And so if we're doing that query and we're doing a sum, I only have to sum to one field. I don't have to do a sum on two fields anymore and then do the math.
Yeah.
So we probably would create some hidden fields.
Okay. So would
just
that
to kind of-
basically reflect the current amount on a certain account, like that?
Right. So this is one table, right? So this is let's come down here. Let's call this a transactions table, right?
Okay.
And we haven't even gotten into which type of data it is. I want to talk about that too.
Yeah.
We probably would also have a users table. I know we will, right? Because we're going to have authentication, but we haven't talked about authentication yet. So we'll get to that, where we'll have a users table, and Matt will be there, and Alexander will be there. Now, whether we want to have the current balance in there, we'll get to that. The answer is yes, we are going to want one, but it's tricky, because things happen when you're moving money. Sometimes things end up not getting there, and you have to undo it, right? When humans are using a system, so if we come back to here, if it's just you and me, we can only click so fast. We can only type so fast. And so we don't really have to worry about me entering 1,000 transactions at once, some of which go through, some of which don't go through, and my balance essentially being off, right? Because they're happening so quickly. But if it's me typing in and clicking a send button, it's probably going to be fine. If you've used PayPal, you've probably noticed that like the money doesn't move instantly. And that's intentional, right? So it's a very asynchronous tool. It's intentional for a couple of reasons. One, because of this issue of making sure, hey, we want to make sure that we know exactly what your balance is before we move this money. And so they're doing it slower than they need to. But also because when I send money to someone in the United States, and I'm in the United States, if I send someone money in the US, person to person, it costs me nothing. The way that companies make money is by sitting on the money. So this is crazy, but there's been Office Space, the movie, is all about like fractions of a penny, right? So imagine that this is the company's account, right? So this is PayBuddy, and this is going to be our transaction, right? Our bank account, where we get the money, we hold it, and then we give the money away. It doesn't really matter, any of this stuff, but let's just say amount. Actually, it'd be debited, credit again, right? But I'm going to add a balance here. And in fact, let's just do date. So if on January 1, Matt paid $1,000 to someone in the US, right? Our balance is now 1,000. Now we got to give this money to Alexander. We got to give it to you. We can't just, Matt's going to get mad if he sends you money and we never give it to the person he sent it to. That's stealing.
Mm-hmm.
So we have to give it, but maybe we don't give it for like a day or two, right? That's fairly common. So
Mm-hmm.
a day or two later, we're going to do it. I'm going to add transaction ID in here just to make it a little easier to see what's going on. Okay, and let's just say 1001, 1001. There we go. Okay, so now our balance is going to be equal to this minus this, and we'll put plus this just to even it out. So now our balance is 0.
Mm-hmm.
So we got 2 days worth of interest. And I'm not going to do the real interest calculation. You can do it. There's a formula in Excel actually to do it. I'm just going to do, let's just say it's 0.001 or something like that. I don't know. Let's just say it's very small, right? Maybe I made 10 cents. Probably made more like 1 cent with interest rates. Okay, but I did that actually every day. So let's do this. Let's add in 112 or 12. Sorry, January 2nd. And so technically, it's this one here. Okay. Let me do it one more time. Equals this minus this plus this. Okay. So this is our company balance is here. And this is going to say times E3. Okay. So I made 2 cents by holding on to Matt's money for 2 days. So a penny a day, we'll just say, for every $1,000.
So then just to clarify, we have like transactions table for the actual users and then our own ledger, right?
Yeah.
Where we
Every business has to keep track of their own money, right?
Yeah. Mm-hmm.
Now, this isn't really the part of PayPal that we think about, but yeah, behind the scenes, of course, they are thinking about their own money. They need to make sure that because it's free for me to send money within the US,
Yep.
and I assume it's free for other people within their countries too, they need to make sure they're not losing money. So they're going to have to, keep track of their costs and how much money they make and stuff like that. And so if 2 pennies is not enough to really pay for this website, well, we might have to hold this money for 5 days.
I see.
And so we've all heard of PayPal, but there's a lot of other tools out there now for sending money between people, especially when you get to other countries outside of North America. You go to Africa and South America. There's a lot of these new startups that are designed to help people send money to each other. They hold the money longer. The default is to hold it longer because they don't have as many people using it yet. And so the only way they have to make money is either charge fees, which discourages people from using it, or hold on to that money and get the best amount of interest you can from it. So 2 pennies here is not a lot, right? Like that's definitely, you can't run a business off of that. But if you scale up and think about how many transactions are happening on PayPal every day, and the fact that once I send this money to you, you're then maybe not going to take it and put it into your bank. You may send it to somebody else, right? And so on and so forth. And it stays within the PayPal bank account essentially.
Yeah.
Right. It's not actually leaving them. So they're accruing interest.
Okay.
And that's where the money really comes from. There is a fee when you transfer across countries. So if I send money to Canada, the fee, depending on how much I send, will be up to $5 basically. But a lot of that fee is not because they want to make money. It's actually to cover their costs. Either there's also another way to make money. We'll get to that later. In currency conversion, I can either gamble and say, here's how much we're going to charge you, or here's how much your $1,000 is going to be in Canada, and hope that the rate is correct.
Yeah.
Or I can give you a bad exchange rate, right?
Yeah.
So if you go to the exchange teller at the airport, you get a different rate than when you go to the bank, different rate than when you go to a store, and so on and so forth.
Yeah.
But anyway, so let's back up. So this is how they're making money. So the goal is to not have a real-time synchronous transaction the way we do when we do a live interaction, like a chat, right? We don't want that. Or this video right now, we're recording this video live. And so, we're sending packets from our computers to YouTube or to LinkedIn. We're doing it live. PayPal doesn't want to be live. They want to be asynchronous. And the only way to be asynchronous is to have a database.
Yep.
And so we have to have one. But we need this database to be able to scale for a lot of data, right? Like a really, really lot of data. And so, but there's two types of data that we're concerned with, maybe even more than two, but two immediately. One is the kind of recent financial transactions that are pending, right? So any transaction that's still in this state where it's been sent but it hasn't been delivered, we need to keep track of that really well. We don't want to ever upset a customer by not delivering the money. If it gets returned for some reason, we need to know that, notify the customer. We also want to really make sure that we never deliver the money twice, right? And it's not that's the most important aspect of handling money. Really, is make sure you don't charge someone twice. Make sure you don't pay someone twice. And so the databases that we're going to use is probably going to be two different databases. One is for anything that we're actively working on, maybe recent transactions. And then we'll probably have another one for archive. Because it's not critical. Those once something is locked and it's done, and we're never going to change it again, we don't have to worry about the database maybe being slightly different in one country than another, because it's already exact, right? So I'm going to go ahead and just widen the cloud, or make it oh, whoa, wrong one. Let's see, I can make it a little taller. Nope, it's not letting me make it taller. There we go.
Perfect.
Yeah. Okay. So we're going to actually have a second database, and this one's more like the data warehouse, right? Let's move some stuff around. So this is going to be our active database, and this is going to be our data warehouse, really. And if you ever use PayPal and do the search activity functionality, and this is not just true for PayPal, this is true for your bank and any other tool, really. Usually you could see, oh, like the last 28 days, last 30 days, some shorter period of time, you see right away. You go to the page and it loads. And then when you want to see more, it has to do some type of AJAX call, or it has to do some type of query, or go to another screen even to see more. And that's because of this type of situation where they're keeping the really critical stuff in one database, and they're keeping the long-term storage in another. These are still subject to change. I've actually had it sometimes where in my bank account, a real bank, not an app, right, but a real bank, where in the middle of the month there was a transaction for a certain amount, but by the end of the month that number had changed because I deposited a check and I typed in the wrong number, right? So this happens sometimes. You read the check, you're like, oh, what does that say? I can't read my grandmother's handwriting. I don't know what she wrote down for my birthday, right? You deposit the check. The bank says, you know what? You put down $1,000. To us, it looks like $1,006, $1,009, or something weird, right? And they'll catch it eventually, and hope they try to catch it within the end of the month. Sometimes it could go to the next month, but you could log in one day and see one number, and log in another day and actually see another number for a specific transaction. And so those are going to be the things in the active database. Whereas once it's locked and like, we're never changing this again, like it is done, the money's moved and you can't change it, then we're going to migrate it down to this data warehouse. And so for the active database, if I were to build this on Google Cloud Platform, I think use Cloud Spanner with a relational database, and it can like handle a lot of data. But for the data warehouse, we don't have to really worry as much about it's still going to be accurate, but we don't have to worry about the timing of things, because anything we put into the data warehouse is locked in time, so we're not going to be manipulating it. So we could probably use like BigQuery, I think, for that, or something even less robust. But we do need to store a lot of data, so that's why I would go with BigQuery.
Yeah, makes sense. Is there like a threshold when we want? So like how much time should we wait after the transaction is complete to move it to the archive?
Yeah, so that's going to vary depending on. So this right now we're just talking. I'm still only talking about sending within this context of the app, right?
Yeah.
So within the context of the app, the timing doesn't really matter. If I send money to you, if you don't accept it, which is not really a thing in PayPal, like the money goes to you whether you want it to or not, right? But if let's say you never log in again, maybe that could happen, right? You lose your username and password, you never log in again. I sent you the money. PayPal's not going to be like, hey, do you want your money back? He never took it. You know, like, no,
Mhm.
it's going to sit in your account,
Yep.
but it's never going to touch the real world. It's really going to stay in the PayPal bank account.
Yep.
But when you log in, you'll be able to see, oh, I have this money accessible to me to
Mhm.
pull into the real world. So from within the app, that could be real time. There's no reason for it not to be.
Mhm.
The problem is the money had to come from somewhere.
Yep.
And typically, you know, especially if you think about, we just launched this new app, PayBuddy. There's no money in it. Nobody has any money. We could give money. We could say, hey, when you sign up, you get $5 free. We could do that, and there might be some reason to do that. Now people could start spending or trading that money without ever talking to the real world. Essentially, we built a crypto coin, right?
Mhm.
And that could be real time because it's not real money at that point. We started with nothing, and we just made up $5 for every person.
Mhm.
That's dangerous to do, obviously, because if I told all my friends, hey, sign up, and then you can withdraw the money, that money has to come from somewhere.
Yep.
And so often, if you look at sign up bonuses for apps, whether it's a money app or a gambling app or whatever, they usually require you to do something first.
Mhm.
Free $5 when you deposit 100.
I
Right?
see.
Banks do that, but real banks do this too. Deposit $20,000 and we'll give you $200 after 90 days.
Mm.
Right? Well, they're doing that because that $20,000 is going to accrue interest.
Yep.
And they're hoping that you don't leave at the end of the 90 days. Some people won't leave, right? Credit cards are hoping that you don't pay the bill. Otherwise, it's free to use a credit card.
Yeah.
But somebody is not paying their bill and is then paying interest, and
Mm.
that interest is really paying for you to use the credit card.
Yeah. Yeah. Makes sense.
But if overnight the entire world became responsible, every credit card company was out of business,
Mhm.
right? Crazy concept, but yeah. Okay, so we have our active database, and that really is real time. We're not worried about that. It's the interaction with the rest of the world that causes all the complexity,
Mhm.
right? Because anything that happens within our app and it's just not talking to the real world is essentially the same as a chat message or an email or anything else that we send, you know, digitally. It's just a record in the database. We're just doing a query, no problems.
Mhm.
And so it's actually a lot easier to build like essentially like a fake currency or cryptocurrency or coins in a game that you can send people. That's like a really simple solution,
Mhm.
which is part of this. But when we start now dealing with the rest of the world, so let's start building some more stuff here. I'm gonna put I don't know what to put. Let's put a big hexagon here. Well, that's big. And this will be my bank. There we go. So we'll put we'll put Bank of America. We'll put okay, and then we'll put your bank over on the other side, right? We'll put CIBC. And I'm
Mhm.
not saying those are the banks we use, but I know CIBC is in Canada and Bank of America is in the United States,
Yeah.
so it works well, right? So these are where our money comes from. This is where we want our money to end up going, right?
Mhm.
When we're interacting. Let's do some arrows. There we go, and this should be a two-way arrow. Let's see if I can get this to look right. There we go. Feel free to shout out if you see two-way arrow. I don't see two-way arrow. That's okay.
Yeah. There
We'll just,
are so many.
yeah, we'll just do it. We'll do it twice is what we'll do. Okay. So we have that, and then we also have let's do that there and that there. Right? Okay, perfect. Even better. Okay. Okay. Oops, sorry about that. Let's see if I can. No. Okay. How did I do that? Somehow. Okay. We'll leave it at this. It's good enough. Okay.
Just.
So this is where the complexity is. It's in the talking to the actual financial institutions.
Mhm.
Now it's really inefficient if we had to talk to each financial institution individually,
Mhm.
right? Because each one might have a different format. Years ago, I did a project with Wells Fargo, and it was like a flat file. that had to be transferred nightly, and that was just really inefficient.
Yeah.
Plus, it was a flat file per account,
Hmm.
right? So just think about that. For every person that was using Wells Fargo, we would have had to create a new flat file and send that flat file over. That's like it doesn't scale.
Hmm.
And then you start adding more and more banks, and new banks get created every year, right? New credit unions, new banks get created every year. There's also consolidation, obviously, which is another whole nother issue you have to deal with. So ideally, we wouldn't talk directly to each bank, right? What we really want to do is talk to something in the middle. And let's go ahead and see if I can figure out where. Here we go. Shapes, more shapes. Let's create a service that we can talk to get all of our work done, essentially. So I'm
Hmm.
going to create this little service here. And there happens to be one. I am familiar with it. It's called Nacha. And it's what the key thing here is ACH, right? So it's called Nacha, and the ACH is in there. And ACH is one of the ways that banks transfer money. Most of us have heard of wire transfers.
Hmm.
But if you think about, and most of us heard of direct deposit when it comes to our paychecks, right? So we do direct deposit for paychecks. That's all done through Nacha. Nacha is how you do a direct pulling of money or direct sending of money.
So is it like a protocol or?
It's actually like a foundation or consortium or something like that. I don't know what the exact term is,
Uh-huh.
but they've established this is how we do it. Nacha itself is like a company more so than the protocol.
I see.
Um, let's get rid of that and get rid of that and get rid of that. And then what I'm going to do is just move these guys up here because Nacha's going to talk to all the banks, and
Mhm.
we just have to talk to Nacha, so it makes it a lot easier.
So basically, all the banks in the world are using this?
I won't say in the world because I'm sure that this started out as a North America thing,
Okay.
but I know it's not North America anymore. It is also international, but in the world is a lot, and there are some countries that are definitely harder to do business with than others.
Hmm.
In fact, PayPal does not work with every country,
Mm.
and it's
Yeah.
because of things like this,
Yeah.
right? So don't worry so much about which countries. I think it's most countries is the
Yep.
key, right? But so we want our app to just talk to Nacha ideally.
Hmm.
If we do need to interact with some other middleware, let's call it, we could do that too for other countries. So let's just say uh, North Korea, right? Like we need to interact with North Korea. Nacha's not going to help us with North Korea.
Yeah.
Um, as a U.S. based company, I don't work with North Korea, but if there were some other countries that did not participate with Nacha because their banking just didn't do it,
Hmm.
we could add that too. But you can see it's a lot easier to scale if this one middleware handles 100 countries, let's say.
Yeah.
So then even if we have to add a couple others for certain areas,
Hmm.
that's okay. It's not the end of the world.
Yeah.
And so this is where things get more complex because this is the actual money that's moving.
Hmm.
Anything that happens within our app, we know how much money Matt has within the app,
Yep.
right? Because it's our database. We know how much money you have within our app. It's in our database. So we won't let you transfer more than you have.
Hmm.
But when we say, oh, take it from Matt's bank account, well, how long is that going to take? And it could be the same day. It could be a month.
Hmm.
It really varies based on the type of account, based on the bank, based on the country, all sorts of stuff. And so that's where that timing issue it comes into play. And that's why sometimes you get money quickly and sometimes it takes a long time to get the money because they're really waiting for the money to show up in their account,
Hmm.
in the PayPal account, making sure that there's no flags that come up a couple days later. And each system is going to have a number of days. So Nacha might have a number that might be 3 days. I don't know. Maybe
Hmm.
it's one day. It also might make a difference whether it's a Friday or a Monday, right? If we transfer money on a Friday, well, there's a weekend in between, and in North America at least, we don't really have banks operating on the weekends.
Hmm.
It might be open as a branch, but the databases essentially are closed, and so you have to wait till Monday for things to kind of be verified.
Hmm.
So it could be 3 days, it could be 7 days, I don't know, but it's going to vary depending on the bank. It's going to vary depending on what medium we're using in the middle.
Mhm.
And so during that time frame, if we were to come back here, this has to have a status, right? And this transaction. So let's think about this transaction. I'm just going to wrap this to make this column smaller. So this transaction is complex. If I want to send money, so let's change this from Matt. I'm sending money to you, right? $10. Let's just say $10. Well, what does it really mean? Well, first of all, we actually probably need to debit Matt's bank account $10, right? And then we also need to credit Matt's PayBuddy account $10, right? That's the $10 from here to here.
Mm-hmm. So you're
And
basically sending money from the bank to the PayPal account or PayBuddy account, and then
right.
okay.
Yeah, exactly. Let's put 2, 3. Okay, and then we're going to credit you $10 at some point. Let's do it one more here. But that also means I need to debit my PayBuddy account or balance. It's called PayBuddy balance, right?
Mm-hmm.
It's a little easier. Not too many accounts. Right? But the reality is this can't happen all at once. This isn't going to be immediate.
Yep.
And this doesn't actually go to your bank account also. This is just to your PayBuddy balance. So this here may not happen till the 10th, right? It might be 3 days. Now, in the 3 days, that's when it actually is hitting the bank account of the company.
Mm-hmm.
So it took them 3 days to get that cash, maybe.
I
Well,
see.
they want to hold on to it for a couple days to get that interest, the interest that we talked about here. So they're not going to credit my balance maybe till the 13th,
Mm-hmm.
right? And then once they credit my balance, then they're going to move the money to you, right? Probably the same day.
Mm-hmm.
Because
Yep.
essentially at that point now I have the money. But before they do, they will check to make sure that I haven't done something crazy and maybe, somehow sent more money than I should have or anything like that, right? So they still are going to make sure that it's okay. Because, things are basically, well, we need a status, right? So this is the status. So depending on what day we're at, the status is going to change. So the very first day when I go to send this money to you, it's probably going to be pending or waiting on bank, right? Mm-hmm. It's never going to be that simple of a word. It's always going to be something like obscure, like pending. But let's just say waiting on bank. And so they're all going to be in the waiting on. They're all going to be in the waiting on bank status on the first day.
Mm-hmm.
On the 10th, when the 10th hits and that money actually shows up in the PayBuddy bank account, we're going to say, great, we got the money, and it's going to be now sitting to earn interest, right?
Yep.
Essentially what it is. And then they're all going to say sitting to earn interest, right? I'm just going to keep this one waiting on bank, sitting to earn interest. Then once that interest has been earned, then we're going to say essentially, okay, payment's done. So, like this one here would probably be like final check or something like that.
Mm-hmm.
And then finally, this is going to be complete.
So are you saying that once, like basically all of those transaction records get created, like when the transaction is only initiated, or they're added one by one?
I don't know the way that PayPal would do it. If this is going to be consistent, I would probably create them all at once. And then that way, when I have to take the next action, it's just a query and an update and not an insert again.
Yeah.
The reason I say that is because you're more likely to create a duplicate if you're inserting records based on transactions that occur, throughout a series of a process, as opposed to just saying, this is our set process. I only save once. I save it when this thing happened, right? So if you think about it, like where's an error likely to happen? Where's a bug more likely to happen? Especially if we're talking about like messages being sent and having retries and things like that. If the error happens at the beginning, Matt says I want to send $10 for Alexander's birthday. If the error happens at the beginning, I'm going to send the money twice. which means that you're taking out of my bank twice.
Yeah.
As a customer, I'm going to be upset that you took the money out twice, but at least the transaction as a whole is going to continue properly, and you're going to get the money twice. So nothing was stolen. It was just accidentally sent more than I wanted to. But if we're inserting transactions in the middle, there's a chance that I send $10 once, but they accidentally give you $10 twice. Right? And that's really bad. And trying to then go back and figure out what happened and why it happened is really, really hard to do. Right? You basically have to spin up a sandbox environment and try to recreate this situation. But recreating situations with integrations is really almost impossible unless this tool here also gives you a sandbox environment. Right? Well, but this tool then has to get a sandbox from B of A and from CIBC as well. It's not going to happen.
Yeah.
And so testing with money in general is really hard. It's also really scary to go live because you never tested as well as you could have.
Yeah.
It costs money to test, right?
Real money. Yeah.
It literally costs you money to test. If you want to test this tool out, you have to send money from your bank account, real cash, to somebody else. And that's so scary. So I would, if I were to build this, I would say, as soon as Matt initiates this transaction from Matt to Alexander, insert these child records as a child of this parent transaction.
Yeah.
And we're going to have a status on there. We're going to have dates on there, and we're going to keep track of every single thing. Now, this record may itself have children too, because we may get a status from the bank or from Nacha saying, "Hey, it's going to take another day."
Yep.
And then we're gonna have essentially like activity or status updates on there. We may get an error saying that bank account was closed yesterday, right? And so or or that it might be just an error saying our bank is closed today. You're gonna have to wait, right? And so all those status updates are probably gonna exist underneath this record, so to speak. It's another table, but it's related. It's a relational database spanner, and then that's gonna bubble up and set the status. Right? So we'll probably have a column called latest update date, expected due date, things like that will be in there also. And that way we can run a query or have a process that runs periodically to look for things that might be a problem. Right? And we'll get to that too. There's, we really haven't built much so far, right? We're just talking about concepts. But high level, this is what should be tracked behind the scenes just to send money from me to you. And then at some point, you're going to get that money, right? And we're going to have another transaction. And this is going to be the transaction where you say, I want to put this money in my pocket. I want to put it into my CIBC account, right?
Yep.
And so we're going to now do the opposite. Let's say you do it a week later, or you do it a month later. Let's just say that. It's fine. So this is going to be another transaction. Let's get the numbers to be consistent there. Let's say on July 1st, you're going to take the money out, right? So we have to remove money from your PayPal balance and put it into your bank account. And this is rarely instantaneous. It's not instantaneous. They don't do it. But we're going to debit this and credit your bank account, right?
Yeah.
And it's probably going to also take a couple days for no reason.
Yeah.
Like, I mean, there is the intermediary. So the Nacha might say, well, we need a couple days just to make sure everything's okay also. So maybe it's on this one and not on PayPal. But it's going to be a couple days, let's just say. And we're going to just call this, putting savings in my bank, something like that, right?
Yep.
And it'll start with, waiting on bank, and it'll end up being complete. And so it's just to move money from one person's bank to another person's bank. It's really two transactions with many child transactions, and each child transaction then has many small status activity updates on them as well.
Yeah, that makes sense.
Yeah. So it's a lot more complex than just a chat message, right?
Where for sure. Yeah. Is it just a quick question, but we still technically it's still possible to expedite that request, right? For example, if the user needs money, I don't know, tomorrow, right? They can pay an extra fee or something to
Okay.
like expedite the delivery technically.
Well, so that would be a feature that we could implement, but
Mhm.
essentially what we're doing there is we're gambling as a company.
Mm.
So, and this is what a payday loan is, which is very common here in the US. I don't know if you guys have it there, but you can gamble and take a loan, take a loan out
Yeah.
from a payment service, whether it's a bank or PayPal or anything else. And that's what they were doing. So if you just sign up today, first day on the platform, you can't do that. They're not going to let you because that's fishy, right? And I know that's
I
the
see.
last topic we're talking about is fraud detection.
Yeah.
That's a very dangerous behavior. Like, hey, I just signed up, and by the way, I would love a loan.
Mm.
Um, you know, and in an app, they're not asking for a huge mortgage application. They're not seeing what collateral you have. They're
Yeah.
not connecting to all of your bank accounts. If you apply for a mortgage from your bank, they ask you for tell me all the money you have, every
Mm.
bank account, every stock account, everything, right? How many other loans do you have? And they're going to try to verify that too. They're not just going to take your word for it.
Mhm.
So usually when there is a feature to get paid faster, first of all, there's a cost to you, right?
Mhm.
So if I'm sending you $10 and they say, hey, you can get paid faster, but it'll only be $7.
Yeah.
They're gambling. They're basically saying they think that that money is real, and they're gonna hope that it's real. They're gonna take $3.
Mm.
Some percent of the time, my guess is it's in this example, it's 30% of the time it's not real, and so they're going to lose that money. But as
Mhm.
long as they're making money from everybody else, then that's okay.
Okay. Okay.
Yeah. So anytime you're offered to get paid faster, you're going to be paying for that service,
Mhm.
and that's where they really make money.
Mhm.
So it's not worth it.
Yeah. Yeah. Makes
Do
sense.
whatever you can to not pay them to pay you faster. They
Okay.
can pay you faster. They should pay you faster, but they make money from fees and holding on to your money for as long as possible.
Mhm. Yeah.
And
Makes sense.
unfortunately, it's not just the interest. That $3 is way more than the interest, right?
Mhm.
They're taking advantage of the fact that you are desperate for that money faster, because the
Yeah.
interest is only pennies probably.
Mhm.
If they said, "Hey, give us the interest, we'll call it even," I would do it every time.
Mhm.
But it's not. They're taking advantage of the situation. So I would not ever do that. But so you're not actually expediting the process of interacting with the banks when you pay that. It's
Mhm.
just a gamble.
Yeah. Makes
Yeah.
sense. I think we have like covered the first feature, right? So sending and receiving money generally. So
Yes.
we have like the ledger system. Um, yeah, about notifications. Obviously, like whenever a certain event occurs, right, we can send it to whatever user we want.
Yeah.
Yeah, yeah, but makes sense. I think what if like currently the only thing is just like two users right now, right?
Right.
So what kind of problems would there be if we have like a million or even a
Right.
billion? Yeah, kind of.
Yeah. So, well, it was one thing we need to talk about is authentication, registration, all that kind of stuff,
Yeah, yeah,
right? So we definitely would want to set up some type of secure login. I typically use Firebase authentication or Google authentication because it's just easy. It's almost just drop in,
yeah.
and you can register with email, you can register with phone, and so that's good. Now, when we send money to somebody in PayPal, I have to typically type in someone's email address. There's other tools where you can send in, with a phone number, like Zelle does phone number, Venmo does phone number, that type of stuff. But so someone has to register. They have to enter in their email address. They have to enter their phone number, and then when I go to pay them, I use that same email, that same phone number. It gets complex when people have multiple emails, right, or multiple
Mhm.
phone numbers. What'll happen is that person's going to get a notification. So we don't have it on here, but we basically need a notification engine in here. Where is it? This one here. Let's create. I don't see a gear. I would love to have a gear. We'll do this one here, but we're gonna need some type of notification engine. Anytime there's a record in the database that the person is not in the database, so we don't have them in the users table, we have to send out a notification to that person, right? Say, hey, Matt's trying to pay you. You want to sign up, right? Anytime that the person is in the database, we need to also send a notification. Matt paid you money, congratulations. So that's going to happen there. Now this can be real time. It could also just be a queue. It probably is a queue. Like I said, PayPal is very asynchronous, and I think it's by design. Because they want to slow this process down as much as possible. Every minute that they slow down is more money that they're making on interest. So there's that there. We have registration. Let's go ahead and put a little thing there for registration. And then what we really are going to have is a lot of these jobs, these processes that are basically just querying the database, looking for records that meet certain criteria, and then taking action on those records. And when they take action on the record, they're going to update the status to say, hey, I'm the process taking action on this right now. So for instance, when this first transaction got saved to the database, it's going to be saved in our active database in Spanner, and it's going to have a status of probably not started yet, right? So it's going to be not started yet. A process, some job is going to be querying the database, looking for records that are not started yet, where the type is get money from Matt's account or get money from a bank account, right? And it's probably even more specific than that. It's probably get money from a bank account where the bank account is registered with Nacha, as opposed to registered with some other entity for Africa or South America or wherever it may be, right? And it may even be more specific, because you want to get these processes to be as specific as possible so that the queries they do are less likely to somehow overlap, and you end up with two processes working on the same record. And so often what I do when I write processes like this, the initial query to find the record gets the record. I then have to do another query right after I say, I'm going to get the record. I'm going to say, okay, this is the record I'm going to work on. I'll actually query it again just to make sure another process didn't get it somehow within those milliseconds. Right? Because it's a possibility. There's other ways of dealing with it too, but basically at some point in that transaction, before we send a message to Nacha, we're just going to double check, triple check. No one sent this to Nacha yet, right? But like I said earlier, the worst case scenario is I send you 2 birthday gifts, which doesn't cost us as a company any money. It upsets the customer, maybe. We might be able to catch it more easily later, though, as opposed to one of the child records somehow being duplicated. That's going to be a lot harder to catch. Okay, so notification engines, registration. Let's just put in some other additional stuff in here. Put on this side. This is going to be our routines or jobs, right? And all they're doing is querying, looking for things that they need to do, and then taking action on those things.
And as you said, those are not synchronous. So it's not that one job finishes and the other one starts. It's they just run daily or something like that, right? So it's,
it doesn't have to. I mean, it's probably more often than daily, because you don't. If you were to do all of these at midnight, and we scale up to millions, it's not going to work. So they're probably running nonstop. But the query is always look for a record where the date is 3 days ago, or greater, right? Look for a record where the date is over some threshold. And this is where things get clever, right? And I don't work at PayPal, but I can almost guarantee you that they're looking at their bank account. And if they ever see, hey, our cash is low today, it happens, right? It can't be the same every day. Our cash is low. Someone goes in there and they adjust that lever, and they say, you know what? Instead of looking for things that are 3 days old, only look for things that are 4 days old today.
Makes sense.
And that way our cash balance stays a little higher today. I don't know if they ever do the opposite, where they say, hey, we have too much cash. My guess is they don't. But it's probably, while we're low, we're going to take a little longer. And once we get back to where we want to be, then we go back to our normal, right? It's probably something like that. But like I said, weekends and holidays get in the way. They probably could also just slow down the number of processes. So if we come back to here, this is multiple processes that are constantly running. And if we don't have enough money, we can be like, you know what, normally we have 100 of these jobs constantly running. We're going to scale it down to 80. So you could adjust the date. You could adjust the how quickly we process as well.
I see. It makes sense.
And the levers probably exist on every step of the process as well, too. So even down to the notifications, right? So we could credit the account and just not tell you for an hour.
Mhm.
And then unless you're logged in hitting refresh, you're not even going to realize it. And so now we held on to your money for a little longer than we would have,
Yeah.
right? We could also send the emails. We could adjust and say, you know what, send those emails at night, because chances are Matt's not checking in the middle of the night. And if he is, he's not going to withdraw the money in the middle of the night. He'll wait till the next day.
Mhm.
So there's a lot of levers that they have to basically hold on to your money longer, and that way they make a little more interest.
Mhm.
Yeah, but that's when you, as you scale up, these routines and jobs, we're going to need more and more of them, right?
Yeah.
We may also need multiple databases. So it's possible that they have a different database per country.
Mhm.
But that means that within those databases, they're going to now have to link to the record in the other database. And so we're essentially going to have like quadruple ledger,
Yeah.
right? We're going to have the ledger on the US side, and we'll have another ledger on the Canada side. And each of them are going to have all four. And now we have to keep those in sync, which is going to slow down our process even more, because we have to now, every time we do anything, we have to double check. Wait, did it change
Are
on
they
the other server?
okay?
Right?
Yeah. Yeah.
I think Cloud Spanner could handle it.
Mhm.
I mean, if we were to pull up, let's go ahead and pull up the docs for it. But like, it says that it can scale to, I think, hundreds of millions or something really high. Let's see. Oh, it may not have it doesn't have an exact number, obviously. But what's important here is actually, let's do this. Let's do BigQuery versus Cloud Spanner, right? Because this is where I think it's important. And I'll make it a little bigger for those of you at home. So Spanner's relational. And again, BigQuery is where I would do my data warehouse of the historical stuff.
Mhm.
So online transaction processing. So that's basically, real-time stuff, which for money is important.
Mhm.
We may not be sending the money in real time, but we need to make sure that we don't do the same thing twice.
Mhm.
Somewhere on here, it's going to say for BigQuery, eventual. We just got to find where it says that. And I probably could eventually. No, it
Right.
doesn't say it on this. It doesn't say it on this side, but here it is. Not designed for strong consistency.
Yeah.
So most of the large databases out there, especially the ones that are non-relational, they're going to have eventual consistency.
Mhm.
You don't take care of that. The system takes care of that. The platform takes care of that eventual consistency. They've essentially have taken care of the infrastructure. So the way that they scale is having multiple databases behind the scenes. It'll eventually be consistent. We don't want to worry about eventual consistency. We want it to be strong consistent. So that's why anything where the money is currently in flux,
Mhm.
it has to be on Spanner or some other relational database that's going to have strong consistency.
Mhm.
I wish it said the number of transactions, but somewhere on here in the docs, it does say the number. We can try searching for it again. How many records? Cloud Spanner. Unlimited scale, right?
Mhm.
So Google's using this internally for stuff that's really important. It's unlimited scale. So we should be able to use this for our active transactions. And that's really the key. Even if we have millions of users, how
Mhm.
many transactions are they doing in the active time frame? And that active time frame, we if we look at the spreadsheet, this is a week, basically.
Yep.
Right? Even if we say it's 10 days, even if we say it's 2 weeks, there's
Mhm.
only so many transactions that can occur in those 2 weeks
Mhm.
versus the history of transactions that we're going to put into our data warehouse, because that's going to just keep growing forever and ever. And maybe we end up sharding that and having this year versus last year, and the search process to search for last year or beyond a certain date is even more asynchronous and complex. I often see that if
Yep.
you want to look at your transactions from your bank from a year ago, sometimes you have to request the report and then they'll send it to you like an hour later.
Mhm.
And that's because they're just kind of reducing the number of records in the data warehouse.
Yeah, that makes sense. But as you also mentioned, like basically the user um is responsible only for initiating the transaction.
Yep.
So, but the other processes, we can basically distribute them so they do not overwhelm our system, right?
Right.
Even
Yeah, we have full control over that. I mean,
exactly.
you need a process these database records fast enough that this database doesn't get out of control.
Yeah.
Right. So the two limiting factors are, one, I mean, although it scales infinitely, you don't want to have records going into the database faster than they're leaving.
Yeah.
Right. And so going back to those levers, the money is the big lever for sure. Right. They're keeping their eye on the money, but the other lever is making sure that this should basically always have a steady state of records. Now it's going to grow over time as we get more users. So you probably are going to have this users table, right? And we're going to have all sorts of stuff like date of birth, and we're going to have last login, right? And we probably also have a balance on there, right? That's going to have to be calculated and things like that. But the last login is important because that'll allow us to have some trend line and see, okay, in the last 30 days, we've had 100,000 people log in. We know the average person does 3 transactions a month. Let's just say 100,000 times 3, 300,000. So now that means that we should have about 300,000 records in our database, active database at any given time. And when I say record, I'm talking about the parent record transaction, not the actual child records or any of the other stuff that support it, right? So 300,000 active money moving transactions at any given time. If tomorrow a bunch of people sign up, well, that number is going to go up too.
Yeah.
But it should essentially be flat-ish, right? We don't want to see spikes.
Yeah, makes sense.
We want to see slow growth, maybe slow dips, depending on time of year. But that line should be as flat as possible on the number of active transactions we're currently dealing with, and that'll be essentially one of the controlling factors whether we spin up more routines or scale down the routines. Yeah, so that's how that works. And if there are laws in place, so again, I mentioned North Korea, right? I'm not allowed to send money to North Korea. I'm not allowed to send money to Iran. I'm not allowed to send money to a couple other, Cuba, right? There's a couple countries. Technically, though, I think someone in North Korea could send money to Iran or to Cuba, right? Like the rules don't work like across the globe necessarily the same way.
Yeah.
So if as we build this app PayBuddy, if we wanted to support those unusual situations, we could just clone the app. And now some of our transactions are in the US realm and some of them are in the North Korea, Iran realm, right?
Yeah.
Totally separate databases. So we don't have to worry about somehow, having too many transactions running at a single time, because it's really 2 instances. We probably have totally different domains, totally different projects, everything, right?
Yep.
And so that may be true for other countries too. Like, I don't know if Venezuela is easy to transfer money to or not. The other thing, like over time, there's now PayPal supports not only consumer to consumer transactions, but consumer to business transactions, right? And so that gets a little more complex too. But instead of having just a users table, maybe we also have a businesses table and so on and so on. So you start to get a more complex diagram of all the entities as you offer more features.
Yeah, makes sense.
Right? Same thing with those loans. That would probably be more tables as well going on in there.
We have around like 25 minutes left. So I think about the second feature, right, that we wanted to cover, multi-currency and cross-border payments. I think we partially covered it, right?
Yeah. So multi-currency we didn't talk about, but cross-border we did. So we basically we can use Notcher or we can use some other medium to send money cross-border if we need to. We're never going to really do it direct. It's always going to be with these are essentially like a banking institution.
Yeah. So basically, like Notcher, do they have their own like APIs that we can interact with or something like that? Okay.
They have their own APIs and then they talk to the banks. Really, the banks talk to them is what it is. But yeah. Okay. So it's a lot easier. This is like, it's like a protocol, but it's at the business level, and then they do provide, APIs.
Yeah.
Currency exchange is tricky. Currency exchange is super tricky because you want the most up to minute rates possible, up to second rates, really.
Yeah.
Not all currencies change that often, but the ones that do, or when they do, really is the important thing. When they do, it tends to be dramatic, right? If something is going to change, like something terrible happens around the world, and now currency is going to adjust, you have to be really careful.
Yeah.
And this is a problem because when I send the money, I'm being told this is what it's going to cost, right? This is, if I send $10 to you, I'm sending 10 US dollars, you're getting a different amount in Canadian dollars. They tell me that up front. And they're basically locking in that amount before they really have the money. Now, if the money's in my balance, that's fine because the money's already moved. They don't have to worry about it. If
Yeah.
the money's coming from my bank, that's where it gets tricky. And they're basically gambling.
Mm.
And so that's why they don't offer a great rate. So if you go to the airport or you go to an American Express currency exchange, you go to a hotel, everyone's going to give you a different rate.
Mhm.
PayPal does not give a good rate because they're gambling. That there's a chance that they take $10 from me, and I actually don't know right now what's 10 US dollars in Canadian. Let's see.
Probably 140. Yeah.
Okay,
Yeah.
1370. So so they're going to say on the screen, when I say I want to send 10 US dollars to Alexander, they're going to say, oh, he's going to get $13.70.
Yeah. Yeah.
By the time you get it a week later, though, this may be down to $12.
Yeah.
And now they're paying you an extra $1.70 Canadian for nothing because they sat on my money for a week. That's why they're gambling that it'll either stay the same or that they'll make money, because it could go the other way too, right?
Yeah.
And I'm not a statistician, but I'm sure it probably evens out a lot.
Yeah. Yeah. They calculate the risk probably, and then think.
And that's also why they're not going to say, oh, Alexander's going to get 1370. They're not going to actually say, you know what, our exchange rate is not that good. He's only going to get $12.
Yeah.
And so you got to get those exchange rates from somewhere. There's different companies that do it. I would recommend going to something that's closer to the bank level. So not just very close to the bank level, right?
Mhm.
There's another entity that does it as well. And of course, it's going away from my head right now. Foreign exchange, IBAN. So IBAN is an international bank account number, right?
Mhm.
And so outside of the US, this is essentially a really long bank account number. It tells you essentially the bank and the bank account at the same time.
Mhm.
And we can type in API. And so I would probably, you can see if you search for foreign exchange APIs, you get so many different places that do it. But I would recommend going as close to the banking industry as possible. Don't
Yeah.
go to someone that sits a degree away that's maybe slightly cheaper,
Yeah.
because the only way to be cheaper with an API is by caching data,
Mhm.
right? We don't want cache data. We want real-time foreign currency exchange. So I would
Yeah.
probably go with IBAN or something like that, where we're really at the institutional level, and use that to get our exchange rates. So let's put that in there. And the key here is, like I said, PayPal's not going to give you $13.70. They're going to give you $12. So they're already lying, right? They're already making money. It's not a lie, but the rate that they give is a discounted rate. They're keeping some of the money just in case.
Mhm.
There will still be a day every year that they lose a lot of money just on the currency exchange because a volcano goes off, or something happens to a politician, whatever it may be, a war breaks out. That's
Yeah.
the day that they lose an insane amount of money on the currency exchange.
Mhm.
There's a couple things they can do to alleviate that. One is they have all this data. So they're collecting every 5 minutes, every 10 minutes, they're collecting the exchange rate, and they're seeing, is it going up? Is it going down? Is it going up? Is it going down? What's the trend over time? What happened 3 years ago when a volcano went off? How many days did it take before the currency got stable again?
Mhm.
And so if they know it takes 3 days after a volcano goes off for the currency to rebound, guess what? You're not going to get that money for an extra 3 days that time.
I see. Okay.
Yeah.
So they can basically postpone the actual delivery of money as well,
Yeah,
right?
they have
Until
all
like.
these levers, and I've seen it where people have said, I've sent money to people, and they're like, "Yeah, it's not coming through," and I'm like, "I don't know. I sent it,
I see.
and
See.
it's just delayed." It said you'll get an email. Your e-check is delayed.
Mhm.
Why is it delayed? It's because something happened, and they're like, "Oh, we're not going to make money on this transaction," and they're betting that if they wait a couple more days, maybe they'll break even.
I
And
see.
it doesn't even have to be your transaction that they lost money on. It could be
Mhm.
somebody else's. It could be that 1,000 other transactions lost money on. They're like, you know what? Let's slow down, see if we can make a little more off of every single person over the next couple of days,
Yeah.
and that way we recoup our losses, because they're constantly looking at the big picture of their bank account and all that interest.
Yeah. Yeah.
So yeah, you make a lot of money when you're dealing with fractions of a penny across millions of transactions.
Mhm.
right? Like, it seems crazy to hold on to $1,000 for 3 days. How much money could you make?
Mhm.
But if you're, a million transactions, even if you're only holding it for an hour, and you're constantly getting new transactions,
Mhm.
you got a lot of money in the bank, right?
Yeah.
1,000 times a million, that's a lot of money. That's $1 billion.
Yeah. About multi-currency wallets, so
Yeah,
generally, like the transactions are not only in USD, right? It can technically
right.
be
That's true.
either Canadian to Canadian or like other
Yes.
currencies, like for example, Canadian to Euro or something
Yep.
like that, right?
Right.
So
So
is basically the only difference that we store like the actual currency in the transaction, or like um
no,
what?
it's going to be separate wallets. Yeah. So like you said, so here I said PayPal, PayBuddy balance, right?
Uh-huh.
But the reality is it's the PayBuddy USD wallet, right?
Yeah.
And then this one is going to be your PayBuddy CAD wallet.
Mhm.
But if I had a CAD wallet, which I can, then the money would come out of that. And so
Mhm.
what we're doing is we're putting an extra layer between me and the money.
Yeah.
That's this one-to-many relationship. Any individual user can now have multiple wallets, and we're really keeping track of that instead of just me as a person.
Yeah, makes sense.
And so we're adding more tables to our relational database.
Mhm.
But there's fewer of those tables, right? So if we have 1 million users, the vast majority of them have one wallet.
Yeah.
Some of them might have two. Some of them might have three. Nobody has 1,000 wallets,
Yeah.
right? Or 100 wallets, let's say, because I don't think there's even 100 currencies to choose from.
Mhm.
So maybe, but I don't know. But it's the transactions that scale, not the wallets, right? So
Yeah.
that's not a big deal. And I don't think PayPal even provides the total roll up. I don't think I can look at what's my net worth, how much money is in my Canadian and USD wallet. They're not even bothering with that, even though it's not hard math.
Yeah.
They're not even just like, who cares? Like,
Yeah.
you do the math. We don't care. So
Yeah.
they treat basically each wallet as a separate user, but those two users have a single sign on,
Mhm.
a single authentication into the app. Really, that's simple. That's not a big deal.
Yeah, makes sense.
The currency exchange is the tricky part, because you do want to make sure that we're not losing money on any transaction. So they change the rate to make it better for them, and then they stall when they need to, right? And
Mhm.
I would be surprised if it's not just, are they losing money today? I would expect them to have this huge amount of analytics, and at this point, they're probably using AI even to guess, hey, are the rates going to change in such a way that if we pay someone today, we lose money, but we could make more money by paying them tomorrow instead of today,
Mhm.
right? Because that's really where the money's coming from. The $5, that's not where they make money. When I send money to Canada, and they charge me $5, and it's only $5 if I send a lot of money. If I send a little money, it's a small percentage. They
Yep.
don't make money off of that. They're making money off of holding on to things and the exchange rate.
Mhm.
Yeah.
Yeah, makes sense. Makes sense. Cool. So then, yeah, multi-currency conversion we did. Fraud detection and security. So
Right.
real-time monitoring, ML anomaly detection, I guess risk scoring, right, and stuff like this.
Yeah. So the first level of security is always going to be an authentication.
Mhm.
Um, so this registration and authentication here. This is going to be what we want to have multi-factor authentication,
Mhm.
for sure. Let's put it off. Okay. Yeah. So we want multi-factor authentication. Some systems will also make you re-authenticate when you send money, or
Yep.
re-authenticate when you withdraw money is very common.
Yep.
Definitely on the withdrawal side. So if you're going to take money out of our app and put it into a bank account,
Mhm.
we're going to make sure we know who you are. If
Yep.
you're going to register a new bank account, we want to make sure we know who you are. Um, Unfortunately, the world we live in, if your email or phone is hacked, it doesn't matter, right? Like
Mhm.
now they have everything.
Yeah.
But if it's just your PayPal app credentials that were hacked, and they
Mhm.
don't have your email and they don't have your phone, they're
Mhm.
not going to be able to do much,
Yep.
because to do something meaningful, they're going to say, hey, we got to do a two-factor. We're going to send you an email, or we're going to send you a text, or you're using like Google Authenticator, or maybe even a key, right? An
Yep.
authentication key, which is going to be the most secure. And that'll prevent the money from disappearing.
Mhm.
Um, so that's the best level of security. If you have the option to ever turn that on, turn it on for all transactions. It's going to slow you down. It's going to be super annoying, but it's means no one will ever steal your money. And so that's important, especially since, you know, I've seen stories online where like, oh, I did, what's this weird transaction? It's only $10 and it says like PayPal fee. Well, someone registered a business called PayPal fee, right? And they went into your account, they hacked in, and they sent that business $10. And you just assume it's, oh, it must be a fee because I didn't have a balance, or I didn't do something. Or you call PayPal support and you're like, why'd you charge me? They're like, we didn't charge you. And it takes an hour to talk to them anyway. So like you hang up.
Yeah.
Stealing $10 is not going to make you rich, but stealing $10 from a million people, you're going to make a lot of money. And so that's what those hackers do. Essentially, they're coming up with these clever ways to look official. You know, we get the texts that look official and things like that, emails. So making sure before we ever send money or remove money or add an account that we do an additional level of authentication with multi-factor is basically what you need to do. Beyond that, they definitely do have probably, again, now it's AI. It used to probably just be queries that would be running, looking for unusual things. So often when I'm in PayPal, I'm sending money to a lot of people at once. I'm sending $10 to you and $10 to all my friends because it's, you know, the holidays. If you send too many transactions at a time within a short time period, that gets flagged. And your screen will go white and you get an error message that says, hey, we need to make sure we know who you are, that you're really a human and that you're Matt. So now we're going to, in the middle of you doing normal stuff, we're going to send you an email, or we're going to make you log in again, or something like that. And so that, again, it's probably now more with AI, but it used to just be a simple routine that'd be running. Hey, look to see if anybody sent more than 5 within a minute, right? Via the user interface, not via the API, but via the user interface. That's definitely fishy, right? You could also say, has Matt ever sent Alexander money before? You know, so if you think about Venmo,
contact list,
the first time you send somebody money, they say, do you want to verify that you know their phone number and their email, not just the handle, you know? And that way you really know who they are. It's the right person, not someone who looks like them and has a similar handle. When I was in college, I had to write a check to pay for college, right? That's how old I am. And every month I would go and I would put the check into just a little box in the basement of the college. We wrote the check out to the name UC Regents, right? That's who you write it out to for my college. And I thought, wouldn't it be funny if I changed my name legally to Ulysses Calvin Regents, and then broke into this box, took all the checks and deposited into my bank account, right? And so that's the kind of fraud now we have to worry about digitally, right? Before it would have been an analog. The bank would have said, hey, how do you have so many checks today, right? And the people who wrote those checks, their bank should have caught, if I had done this, I didn't do it, their bank should have caught, you know, normally this gets deposited into this other account, which is an institutional account. Today it's being deposited into some random guy who just opened up his bank account yesterday. That should have been flagged, right? And so it's the pattern or the deviation of the pattern that AI or query with some process is going to look for now. I'm sending money to someone I've never sent before. I'm sending too much money at once. I'm sending money to countries that I never send money to, right? All of those should be flags. And then there's some risk analysis where PayPal is going to decide, is this something we want to stop and ask more questions before we go any further and protect our customer? Or are we going to let it go and ask questions afterwards, hoping that, you know, we have a good relationship with Nacha and these banks? Or are we just going to let it go and wait to see if Matt complains that someone stole his money, and then we'll tell him tough luck? And I don't know how they decide. I'm sure a lot of it has to do with the amount of money being sent, but also where it's being sent to. If it's being sent to a country that we're not on the best terms with, or it's not through Nacha, it's through one of these other mediums that maybe it's not as easy to work with, then they're probably going to be more aggressive on the fraud detection. But if I'm sending money from B of A to B of A, and it's a long-time customer and I'm a long-time customer, they probably don't care.
Yeah, makes sense.
You know, the risk is so small. And at the end of the day, you know, when we sign up, we're agreeing to the terms of use and all that stuff. So it's on me for having a password that's 12345, right? That's my fault.
Yeah, makes sense. Yeah, so it's basically a lot of parameters, right, that we keep track of, and yeah, smart
Yeah,
models.
right. They
Yeah.
do have IP address, so like when I log in, they're going to see my IP address. And if I log in always from the same IP address, or at least from the same city, when
Yeah.
I log in from a different IP address, they should be saying, "Wait a minute, what's going on here?" You know, I see a login that doesn't look like you, right?
Mhm.
Same thing. There's cookies on my computer. If I log in from a brand new computer, if I clear all my cookies, they should ask for that additional verification, the two-factor, and
Mhm.
so that's also helpful. So there's
Yeah.
a lot of data. There's a lot of data that they get, and that should be used to kind of look for potential fraud.
Mhm.
Um, Real fraud at the end of the day, if someone wants to rob you, they're going to rob you, right? Like someone, you know, you look at the movies, right? Like an Ocean's 11. You know, if they have that much skill and that many people working on it, they'll find a way to rob you.
Yeah.
But it's the simple ones that we're able to kind of stop using just analytics and taking an extra step to do two-factor and things like that.
Yeah. Yeah. Makes sense. Cool. Awesome. I think maybe one last question
Sure.
before we end the session. So we have like those hexagons, right? Registration and auth and notification engine and stuff and jobs. And then we have databases, right? But should we maybe just to clean up this diagram a little bit,
Yeah.
or would there be some kind of like dedicated services that like basically that could be scaled up or scaled down, right? Because like we do not interact with the database directly, right?
Right.
So I guess and what kind of services would we need to have, right?
Right.
So
So we obviously need some type of web app, right?
yeah,
And we probably are going to have a mobile app that talks to our APIs as well.
yeah.
The web app will probably just talk with the APIs also. Um, I don't know. You choose a shape. Let's do
Oh,
Twitter.
okay, it's hard. Yeah, that works.
We're gonna have a website. We're gonna have our APIs, and our mobile app will just talk to the APIs, right?
Mhm.
Let's do a mobile thing. This will be mobile here. Here we go. Looks like a switch,
Yeah.
right? And then we also have our routines, right, that are talking to our databases. Whoops,
Mhm.
and so stuff is moving. So really, this is the key to it. It's these routines or jobs
Yeah.
that are constantly looking at the data and then determining what needs to happen.
Mhm.
And this is going to also talk to Nacha, up here,
Yeah.
all that stuff. It's that's what it's really about. It's these here things here.
Mhm.
Um, there's probably some admin panel where they can, if they unless they fully automate it, which PayPal they probably have,
Mhm.
but they probably have fully automated control where it's doing the query not just of the records in the database, but like, hey, how much money do we have? Well, we don't have enough. Okay, it automatically knows to scale the processes so they
Yeah.
run slower or take longer, that type of thing. But yeah, this is where it's going to scale really. The website I'm not too worried about
Mhm.
because it's humans using a website.
Yep.
And the page loads, if actually it's funny, if you log into PayPal today, they just changed their UI again, and it's so hard to find stuff. But
Mhm.
that's intentional, right? They make it hard to find stuff, so it's hard to get your money out,
Okay.
right? It's always hard to get your money. They want the money in there for sure. They want you to put money into your account. They want you to get money, but it's really hard to get your money. You have to find the right place. And so even down to the seconds that it takes a human to figure out where to click, they're making money.
Mhm.
As crazy as that sounds, like, but they know how much money they're making, right? They can calculate by making our UI a little more complex, we're going to make this much more money. It might be a fraction of a penny for me for today,
Yeah.
but across millions of users for the whole year, it's a lot of money.
Yeah, I am.
And so they're constantly changing the UI. They're constantly making it harder to figure out how to get my money out.
Yeah.
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 Um,
Awesome. Yeah, I think we uncovered a lot of like perspectives generally, right? As you said, like how PayPal thinks
yeah.
about all the transactions, and it was very interesting. Thank you so much for that.
Yeah,
Uh,
of course. This has been fun.
yeah, perfect. Then, thank you so much to our attendees as well. And yeah, hope to see you at the future events. And thank you so much, Matt, again for the great session. So yeah. Have a great weekend, everyone, I guess.
Bye.
Bye bye.